So yesterday we did just basically one-step inequalities where you either add or subtract or multiply and divide. So we're just going to move forward, adding in all the stuff that we did with equations. All right, so this is multi-step. These are pretty straightforward. We're going to do several of them together. When I have something like this, I am going to treat it just like an equality. I'm going to do exactly what I would do to solve. So I have 3x plus 5 is greater than 20. And so I'm going to do the same thing. I would subtract my 5 from both sides. Once I do that, I am going to cancel it out on the left-hand side. On the left, I also have the 3x left over. I am going to bring down this greater than sign. 20 minus 5 is 15. And my last step here is to divide. So I'm going to get x is greater than 5. And so if I were to graph this particular one, I would do an open or closed circle here. Open or closed circle. Yeah, I would do an open circle rather. And where would I do it? Yeah, so I'm going to do an open circle on the 5. My x is bigger than 5, so I'm going to do all my numbers larger than 5 there. All right? Look at the next example. For this one, my first step is going to be to subtract that 8 over. So I'm going to subtract 8 from both sides. It's going to cancel on the left. I'm left with just negative x over 3. Greater than or equal to 12 minus 8 gives me 4. What's happening between the x and the negative 3? Division. So how do I get rid of it? You multiply. So I'm going to multiply by negative 3, multiply by negative 3. Over here we're going to cancel and I have an x. What about this guy? It flips. I multiplied by a negative 3, so I have to flip it. So 4 times negative 3 gives me negative 12. So on a number line, I am going to go to negative 12. Open or closed circle on negative 12? Closed. And do I go to the left? Is x smaller than negative 12 or bigger than negative 12? Smaller. And so I'm going to graph that way. All right, so we're doing the same process. The only thing that's going to change is the positive negatives. We're going to treat this exactly the same at this point. We are going to distribute that negative 3 through. So we're going to start and leave this 4x alone. We are distributing a negative 3 here. So negative 3 times positive 2 is negative 6. Negative 3 times positive 2x is negative 6x greater than 10. The only time we change the sign is when we move it across. So if we are just combining like terms, you don't change your signs here. All right. So this 4 and negative 6x are like terms. I'm just going to combine those. 4 plus negative 6x is negative 2x. And then I have that minus 6 greater than 10. And then now I have a basic two-step equation here. I'm going to add my 6 to both sides. On the left-hand side, it cancels. I have negative 2x. Bring down your greater than sign, and 16. And then my final step here is to divide by that negative 2. I am dividing by a negative. So when I bring this down, I do need to flip it to a less than. 16 divided by negative 2 is negative 8. And once again, when I do this process here, I am going to graph it. Open or closed circle. Open circle, all right? So open circle at the negative 8. And then is x smaller or larger than negative 8? So I'm going to go to the left. So just like with equations, we added one more level of solving here. Multi-step, and then we had variables on both sides. And so we are going to simplify each side as much as possible. then we're going to move our variables to one side and our numbers to the other. And so again, we're going to start with leaving that x plus 4 alone, greater than or equal to, and we're going to distribute this 5. 5 times x, 5 times 6, and then we still have that negative 2x there. Again, we can't simplify the left at all. We're going to leave that alone. When you simplify this, you do not change the signs. You only change the signs when you're moving it over to the other side. So I just have 5 minus 2 here, right? So I have 5 minus 2. Now I'm going to move variables to one side, numbers to the other, okay? Sometimes here, people always want their variables on one side. So if you always want to put your variables on the left-hand side, that's perfectly fine. Some people want to make sure they don't divide or multiply by a negative if possible. And so then they move them. That's usually what I do. So like in this case, I would probably move the x over to the right and I would move the 30 over to the left. Either way, though, when you do this, you're going to have to be dealing with negatives because 4 minus 30 is going to give you a negative, but you won't end up dividing by negatives. So I'm going to show you both ways just in case you want it one way or the other. All right, so if I were to subtract my x's over here, that means that I need to take the 30 and move it to the other side. So I would need to subtract my 30 and move it over here. I need to make sure if my variable cancels here, that my number cancels on the other side, okay? They should cancel on opposite sides. My number should cancel on one side. My variable should cancel on the other. So I have 4 minus my 30 here. And what am I going to get? Negative 26. I haven't done any multiplication or division yet, so that doesn't change. And I have 3 minus 1 gives me a 2x. And so now I'm dividing by a positive 2. So I get negative 13 is greater than or equal to x. If I had done it the other way, so let's say you always like your variables on the left-hand side. You still then want to make sure that I am going to move my x's to one side. Then I would move my numbers to the other. So in this case, I want to make sure that my x's cancel on one side again. My numbers cancel on the other. So I have x minus 3x, negative 2x. Bring down your greater than or equal to. 30 minus 4 is 26. In this case, I am dividing by a negative 2. Negative 2. So I get x, and I have to flip this sign here. Less than or equal to negative 13. All right? So when I graph this, I have, obviously I'm at negative 13. Either way, it's going to be a closed circle, right? Either way, I have a closed circle because they're both or equal to. All right, on this side, is my x smaller or bigger than my negative 13? Smaller. Here, is my x smaller or bigger than my 13? Smaller. So both ways you're going to see you get the same exact answer. It just looks different. Make sure you graph it correctly no matter which side your variable ends up on. All right, this first one, you're going to add 7 to both sides. All right, so we get 8y is greater than what? 24. And then what's our last step here? Divide by 8, right? Yeah. So we get y is greater than 3. Bless you. So when we graph this, open or close circle at 3. Open, right? If it's just greater than or equal to, if it's just greater than or just less than, then you do open. If it's or equal to, then you do closed. Is y bigger or smaller? Right, so we're going to go to the right. All right, look at the next one. We need to combine like terms first. 4a and negative 6a give us negative 2a minus 4 is greater than 10. We're going to add that 10 to both, add that 4 to both sides. Negative 2a is greater than 14. All right, what's my last step here? Divide by my negative 2. I am dividing by a negative. So A, and what do I do with the sign? Flip it. 14 divided by negative 2 is negative 7. So A is less than negative 7. So then if I graph this, open or close circle on negative 7. And is A bigger or smaller? Smaller. All right. For this one, I have variables on both sides. I can't really simplify either side. They're both simplified. So I'm going to move my variables to one side and make sure that those cancel. And I'm going to move my numbers then to the other side. All right. And also make sure that those cancel on the other side. When I do that, I get 5 plus 2 gives me 7 is greater than or equal to 9n's minus 4n's. Right. And I'm going to divide by 5. So I get 7/5 is greater than or equal to n. All right. When I graph this one, I'm going to go to 7/5. Open or close circle? Close. Is n smaller or bigger than 7/5? N is smaller, right? Quick note here. What two numbers is 7/5 in between? If I were to graph this like on a number line, it's in between 1 and 2. 5/5, which is 1, 10/5, which is 2. So when you graph this, I'm not going to measure and make sure you're exactly 2/5 away from 1, but I will make sure you're in between 1 and 2 when you graph it, okay? So just make sure you know how to graph your improper fractions. If you need to change it to a mixed number, do that because you'll see it's 1 and 2/5, and that should tell you where to graph it. A rectangular garden here. So we have a person that is fencing a rectangular garden, has up to 60 feet of fencing available. If the width must be 5 more than half the length, what are the possible dimensions of the garden? All right. So anytime you have this, I would actually recommend that you draw a picture. All right. We have a rectangular garden. So we're going to draw a picture of a rectangle to get an idea of what's going on here. We have a length and a width. We don't really know what those are, but we know the length and width make up the fencing. Fencing represents perimeter, right? We put the fencing around. If I were like laying sod, that would be the area, but this is fencing, so this goes around the outside, okay? So I do have to recall my perimeter equation for a rectangle. What is my perimeter equation for a rectangle?
2L's plus 2W's.
Right, add up all your sides. You have 2 L's and you have 2 W's here, right? Just add them up. While I don't know what they are, they do give me a relationship. It says the width must be 5 more than half the length. How do I write half? So this must be, that means W is going to be what? Half the length. How do I write half the length? 1/2 times what? Or divided by 2, same thing. So 1/2 times what though?
60.
It's a variable. They're telling us half of what? The length. So I'm going to say the width is going to be half the length, right? And 5 more. How do I write 5 more? Plus 5. All right. So my width is going to be half the length plus 5, right? Now, instead of this equation having 2 variables, I am just going to replace my W with what I just said it to be, 1/2 the length plus 5, okay? So I'm going to rewrite that equation, and I'm going to say, well, the perimeter is going to be this now. I'm just replacing my W with what they told me W was. W is 1/2 the length plus 5. Now, 60 is not what it equals. All right, 60 is what he has. In fact, it says up to 60. So that means that this perimeter here, this perimeter that I just came up with, compared to the 60, can only be up to 60. So is this perimeter going to be less than, greater than, less than or equal to, greater than or equal to 60? Less than or equal to, right? Up to means we can go all the way up to 60, but that's as much as we have. All right? So that means that the perimeter that I get here has to be less than or equal to the amount of fencing I have to put around it. All right? Once you figure out the setup, you have a basic problem to solve that we've already been doing. All right? The setup's the hard part. Okay? So once I have this, I'm just going to solve it. I'm going to distribute, combine my like terms, and solve. So I have a 2L here. 2 times 1/2. What's 2 times 1/2? It's just 1. So I have L. Then 2 times 5 gives me 10 there. Less than or equal to 60. Combine my like terms. I have 2L and 1L. How many L's do I have on that side? 3 L's. How do I get the variable by itself? What do I need to do? Subtract 10. It cancels on the left side. I have just 3L. Bring down your less than or equal to. 60 minus 10 is 50. All right? Now I will say in this case, so I am going to divide both sides by that 3. I have L is less than or equal to 50 thirds. You don't want to write dimensions in improper fractions. So normally I would say leave it as an improper fraction. However, like I've said before, if you were to go to Lowe's and say, hey, I need 50 thirds of a piece of lumber, they would look at you like you were crazy, right? We're talking about feet. So when you're talking about lengths of something in feet, you do want to make it a mixed number. So how do I make it a mixed number? What do I do with the 50 and the 3? Divide, and my remainder becomes a fraction, right? So how many times does 3 go into 50?
16.
Yeah, 16. And how much do I have left over as my remainder? 2/3. So 60 and 2/3 feet. All right. Now, having said that, I need to solve for my W, because it actually said the possible dimensions of the perimeter. So there's 2 ways to do this. They actually put these in inches. So I have 16 feet here. How do I figure out how many inches this is? 2/3. How many inches are in a foot?
12.
12. So I need to take my 2/3 and I need to multiply that by 12 inches to figure out how many inches I have. I have 2/3 of a full foot, which is 12 inches, right? So I'm just going to multiply, cross cancel here. 3 and 12 cross cancel with a 1 and a 4, right? So 2 times 4, how many inches is it? 16 feet and 8 inches. So my length has to be no more than 16 feet, 8 inches, right? Make sense? All right. They also want us to tell the W. So with the W, I would actually plug this in like this, more than likely is what I would do. I would just plug in the 50 thirds and solve for that. So I would say 1/2 times 50 over 3 plus 5. I can cross cancel here. 2 and 50, how do those cross cancel? 1 and 25. All right. Now, a little trick here. I'm adding 25 thirds. I know fractions are your favorite. All right. I would actually make that 25 thirds a mixed number as well before I added. Instead of getting a common denominator here and then having to just divide it right back out, go ahead and make that a mixed number as well. All right. What is 25 thirds as a mixed number? 3 goes into 25 how many times? 8, right? With what left over? 8 and 1/3 plus 5. That's much easier to add, right? This is just going to be 13 and 1/3. Okay? So for my width is going to have to be no more than 13 feet. And I'm going to do the same thing with this 1/3. Okay? I'm going to take that 1/3 just like I did the 2/3 and multiply it by 12, right? Those will cross cancel. So 13 feet and 4 inches. Okay? So don't let the conversions throw you. Don't let the conversions throw you. So while it reads at the very beginning and it starts with Heston earning twice as much as his sister, and then she makes more than her brother, you'd think that the variable would be with just Naomi. But you need to actually start with Jake and work your way back. We don't know what Jake makes, so we're going to put an X there. We know that she makes $30 more, so $30 more would be X plus 30. And then we know that Heston makes twice as much as that, so we're going to say twice of what hers was and just make sure you put parentheses there. The rest of the problem tells us that their salaries are at most $330, which means if we add up all of their salaries, the X plus the X plus 30 plus the 2X plus 30, it is at most, what am I going to use there? What inequality? Less than or equal to. So that 330 is the very most they can earn, which means that 330 is going to be bigger than everything we have on the left. So now I'm just solving. I'm going to distribute here. So I have X plus 30. 2 times X is 2X. 2 times 30 is 60. Combine your like terms. 1X, 1X, and 2X's are going to give us 4X. 30 and 60 give us 90. Subtract my 90 from both sides. I get 4X is less than or equal to 240. And my last step is to divide. So X is less than or equal to 60, which means that Jake makes no more than $60. Naomi makes no more than $90. And if we double that, Heston will make no more than $180.